Hello and welcome. This is a pre-algebra video where we are continuing our discussion of order of operations and evaluating expressions. In this video, we're on page 11 and we will be working on numbers 9 through 12. And on page 12, we'll do the top two problems there. So let's take a look at number 9. I'm going to write GEMDAS here, so I remember that I need to evaluate grouping symbols first, then exponents, multiplication, division left to right, addition, subtraction left to right. One thing I need to look for first, of course, is grouping symbols. And you may not know this, but square roots are grouping symbols. The other grouping symbol I can see here are the absolute value bars. So I know I have to solve my square root first and what is inside the absolute value bars first. So what is the square root of 225? I can certainly put that in a calculator, or I can say, hey, I wonder what number multiplied by itself equals 225. I know it's 15, so the square root of 225 is 15. This is read as divided by 5, fractions are division, plus the absolute value of negative 10 plus 6. Still working on the grouping symbol, I have 15 divided by 5, and that's going to be plus the absolute value of negative 10 plus 6. I can put that in a calculator, or I can do that in my head. It's negative 4. You're going to note that the absolute value bars remain until you ask yourself the question, how far is this one lone number? I've got to evaluate first, but how far is negative 4 from 0? Well, I know that it's 4 spaces away from 0. So my next step, I'm done with grouping, no exponents, looking for multiplication and division. This is division. So 15 divided by 5 is 3, and that's 3 plus 4. And the last step is 3 plus 4, and the answer is 7. Now, number 10 looks very similar. I do have a square root. I know that's a grouping symbol, so I'll be evaluating that fact first. And I've got parentheses, not absolute value this time. I have a 2/3 in front of the parentheses. That does indicate multiplication, 2/3 times whatever the product is. Let's find our square root of 100. Put that in the calculator, or if you know that 10 times 10 equals 100, you know that the square root of 100 is 10. It's going to be divided by negative 10 plus 2/3, and I will do this piece in one step. I did my first grouping symbol, and I'm going to do my next grouping symbol in the same step. I have 2/3 times negative 5 times 15, and that is negative 75. Alrighty, no exponents, but I do have multiplication and division. I'm going to divide first. 10 divided by negative 10 is negative 1, and that will be plus 2/3 times negative 75. Multiplication, right here, I've got to multiply 2/3 times negative 75. Certainly you can do this in your head, but if you can't or you want to use Desmos, you are allowed. So I have negative 1 plus negative 50. I have negative 50 because 2/3 times negative 75 is negative 50. What is negative 1 plus negative 50? Last step, it's negative 51. Okay, number 11. Wow, look at this. This has so much. This has another grouping symbol. Actually, this has a lot of grouping symbols. I've got the square root. I've got absolute value. And I also have what I call it's a long fraction bar. You can clearly see that there are operations to perform in the denominator and operations to perform in the numerator. When you see a long fraction bar like this, you need to separate or treat the numerator and the denominator separately until you have one number in the numerator and one number in the denominator. So I'm going to treat each one as its own separate piece. Let's take our first step in our denominator. I have negative 4 plus, I know this square root is a grouping symbol. Within the square root, I have an exponent. I don't have others grouping, but I do have an exponent. So I must find 7 cubed first. I can put that in the calculator, and 7 times 7 times 7 is 343 minus 19. So I have completed one step in my numerator. Now I will complete one step in my denominator. In my denominator, I just have these parentheses, or absolute value bars, which represent a grouping symbol. So I must multiply 6 times -4. So in my denominator, I now have an absolute value of -24. I'm now going to go to my second step in each, the numerator and the denominator. I still have the grouping symbol in the numerator, 343 minus 19. So I have -4 stays, -4 plus, and it's going to be the square root of 343 minus 19, and that's 324. In my denominator, I just have one number inside absolute value bar, so I can ask, how far is -24 from 0? Well, it's 24 spaces. The denominator is now done, but I am not done with my numerator yet. Still have that grouping symbol, so I have to find the square root of 324, either in the calculator or by knowing that 18 times 18 equals 324. So the square root of 324 is 18, and I have one final step in the numerator. I'm going to put this -4 plus 18 is 14 over 24. This is a great answer, but I'm not fully done because I must simplify all fractions. 14 and 24 are even numbers, so I can always divide even numbers by 2. 14 divided by 2 equals 7, and 24 divided by 2 is 12. 7 and 12 do not have common factors, so this is a fully simplified fraction. Let's take a look at number 12, which of course was 11, but we already have 11. So number 12 also has this nice long fraction bar, so I know I have to evaluate what's in the numerator and then evaluate what's in the denominator. I might end up with a fraction, or maybe I'll end up with a whole number. Let's take a look and see. In the numerator, under the square root, which is a grouping symbol, I have an exponent. There are no other grouping symbols, so I'm going to take 3 squared. So I have the square root of 3 squared, which is 9 plus 16, and that's minus 15. And this negative sign right here, I'm just going to keep, and I have to evaluate what's in the parentheses. 2 times -1 is -2. All right. Now, under my square root is 9 plus 16. That's 25. So I have the square root of 25 minus 15 over the opposite of -2. Negative is a positive 2. Still have to take the square root. I know 5 times 5 is 25, so the square root of 25 is 5 minus 15 over positive 2. I'm sorry, it's minus 15. I don't know why I wrote a 10 there. And 5 minus 15 is -10 over a positive 2. My final step, I could simplify it. I'm also going to say, my numerator is larger than my denominator, greater. Does 2 go into 10 evenly? It does. -10 divided by 2 is -5. All right, moving on to page 12, we are going to evaluate these expressions with the replacement value of x equals 2. I changed the numbers to 13 and 14. So I know that in between this x cubed and 5 is multiplication. I'm going to substitute in 2 cubed. I'm going to write GEMDAS. There are no grouping symbols, but there is an exponent. 2 cubed is 2 times 2 times 2. You can put that in the calculator, or you can know that 2 times 2 times 2 is 8. 5 times 8 is 40. I think after 12, that one seems pretty approachable. Now, what you're going to notice is this is 5x cubed, and in here it's 5x in parentheses cubed. Same number. I'm going to substitute 5 times 2 cubed. In this case, I do have parentheses, so I have to multiply the 5 times 2 first. Remember, over here, I cubed the 2 first because it wasn't in parentheses. That is 10 cubed. 10 times 10 times 10. You can put that in the calculator, or you can multiply it out and know that this is 1,000. These two problems, I think, really highlight how important it is to follow the order of operations. Parentheses matter. That's it for this video. Thanks so much.